In this video, we're going to be doing some guided practice on the 2019 Junior Cycle Science paper, and we're going to be looking at question 4. So what was question 4 in this paper? Question 4 was on the conservation of mass during chemical reactions. So it was a 15-mark question, which means that we have 5 minutes. So get your timer, set it for 5 minutes. Okay, start your timer now. We're going to start reading the question. Okay, so what does it say? It says natural gas contains methane, and the methane formula is CH4. Might be important, so I'm not highlighting it. It says methane is a fuel. Okay, so what type of substance is it? It's a fuel. And fuels like methane burn in oxygen to produce carbon dioxide and water. So we did this during chemical reactions when we looked at combustion reactions. We then have diagrams which kind of represent the reaction. So here we can see methane. So this is methane represented by the yellow circle with the 4 blue circles attached, and we react these with 2 molecules of oxygen to produce, that's what the arrow means, it produces CO2. So here's a CO2 and 2 of these H2O molecules. And the main thing to point out here is that the things on the left-hand side here, these CH4 and the 2 O2s, these are what are called reactants. And the things on the right-hand side, these are called the products. So again, all of that we have done before in great detail. That should not pose us too many difficulties. So let's go to see what they actually ask us to do. It says to count. So what they're asking us to do, that's the action word, to count. Count the number of each type of atom in the products to complete the table below. So we have this table. So what I need you guys to do is I need you to either look at either do it fill in the table here in the exam papers if you have them, or else make a copy of the table. If you need to make a copy of the table, go ahead, pause and do that now. Okay, so the first thing I want you to take a look at is what they've already done here. They've already counted the number of atoms in the reactants for us. So as you can see, carbon, well, there's only 1 of them in the reactants over here. Okay, so they've said a number 1 here. So let's do that together now for the number of carbons. Okay, so the number of carbons in the products. So let's count them. Well, I only see the 1 yellow circle here. So my answer here is going to be 1. So there was 1 in the reactants and there's still 1 in the product. Okay, so what I want you to do now is pause the video and complete the table for hydrogen and oxygen. Do that now, please. Pause the video. Okay, so you should only be watching if you have completed the table. And hopefully you counted that there were 4 hydrogen atoms and there were 4 oxygen atoms in the products. Okay, so what I'm noticing here is I'm seeing a pattern. This should be jumping out at you in that whatever atoms were there before, each type of atom, there's still the same number of them afterwards. Okay, and that's ringing a bell for me here, something that we learned about called the conservation of mass. Now, this isn't part of the question where I asked you to explain this, but I know you guys can, so this is a bit of revision. What I'm going to get you to do is pause the video and speak out the answer, or else pause the video and write down the explanation. What is the conservation of mass? What does it say? Pause the video and do either of those 2 things now. Okay, so hopefully when you pause the video, you either said or you wrote down this. The conservation of mass says that atoms or matter cannot be created or destroyed. Atoms can just be moved from one place to another or moved around or rearranged. Okay, so that's what we're talking about. I'm not going to explain that in any more detail because we've done that before, but a reminder of what the conservation of mass says. Okay, so look, the next question is actually about that. It says mass is conserved during this reaction. It was telling you that it is conserved during this reaction, and it's asking you for evidence of this. Okay, so I'm going to get you to write down the word evidence either in this box on your exam papers or in your copy. Evidence that mass is conserved. Pause the video and write down a piece of evidence that shows mass is conserved. Okay, so again, you should definitely look up at your table here or look up at the diagram when you're doing this. If you didn't do that, then you need to pause the video and look at the diagram for the clue here. Okay, so let's go. Let's think about this. Well, I see that there was 1 carbon atom in the reactant, and it's still 1 carbon atom after the reaction. There was 4 hydrogens before the reaction, and there's still 4 hydrogens after the reaction. There were 4 oxygens before, and there's still 4 after. So the number of each type of atom hasn't changed. No atoms have been created or destroyed. There's no extra atoms there, and yet there's no less atoms. So this is what we mean by the law of conservation of mass. So how would we say that? We would say the number of each type of atom Okay, so again, if you weren't able to do this, pause the video, finish this sentence now. Okay, hopefully you were able to do it. And if you weren't, hopefully you're able to finish it now with my help. So the number of each type of atom, what we say about it is the same in the reactants, or for the reactants, you could say, in the reactants and the products. That's not the only way you could say this. You could say the number of each type of atom hasn't changed. You could say the number of each type of atom is the same on both sides. That's kind of the same thing, but you should definitely be talking about the number of each type of atom. That should definitely be in your answer. That's what the table shows us. Okay, so hopefully you got that right. Let's move to the next bit now. Okay, so reading the next bit, part C, it says the burning of methane is an example of a chemical change. Describe one difference. So it wants us to give one difference between a physical change and a chemical change. Okay, so when we're asked for a difference, a top tip here is that we can use a table to show us difference. So what I'm going to do here is we're going to do physical change on the left of the table, and we're going to do chemical changes on the right of the table. I want you to describe what are one difference between them. There is one main one. There might be a few other ones that might be acceptable as well. Pause the video, write down what is the main change, the main difference between these two types of change. Pause the video and do that now. Okay, so if you weren't able to do that, here's a little bit of help. A physical change is something like taking an ice cube, which is water, and melting the ice cube to give you liquid water. Okay, the substance though is still water. So there's a clue, that's a physical change. Whereas up here, this is a chemical change. So as you can see, the substances before and the substances after are not the same. So this here is not the same as this. It has changed. So I've given you a clue. So if you weren't able to do this, hopefully you can now pause the video and complete this table about the difference between chemical changes and physical changes. Okay, so you should only be playing now if you have a final answer for this. Chemical changes and physical changes, the main difference is that physical changes don't make new substances. So no new substance. So an ice cube is water that is solid, and then you melt it and that changes it to water that is liquid. It's still water though, it's not a new substance. Whereas chemical changes make new substances. Okay, that's the main difference. For example, up here, methane is one type of substance. Carbon dioxide is a different substance. It's got one of the same atoms in there. It's got the carbon atom, okay, but it's got different atoms joined to it. This one has 4 hydrogens, whereas the carbon here has 2 oxygens joined. Different substances, okay, so this is why this is a chemical change. All right, so we're going to go ahead and pause your timer, and we're going to use the Markov scheme now to correct this. Okay, so let's take a look. Markov scheme here has 3 marks going for part A. So as you can see, part A here has 3 marks, 1, 1, and 1. And the order here in the table, the answer is 1, 4, 4. Okay, so that's what we have here, 1, 4, 4. And each of them is what, 1. So that's a total of 3 marks. The next thing is part B here. As you can see, this is part B. Part B. It says mass is conserved. What is the evidence for this? Well, what have we said here? There are equal numbers of each type of atom on either side is what it said. What have we said? We've said the number of each type of atom is the same. So that's the same as saying it's equal, okay, in the reactants and the products, which is the same as saying on either side, okay. So our answer isn't exact word for word for that, but hopefully you can see that they mean the same thing. It's really important we only give ourselves the marks for the answer if it means the same thing. If it's kind of similar, then no, we want to be right, okay? And we are still right. We have said the same thing using slightly different words. It was worth 6 marks, okay? So we're going to give ourselves 6 marks there. The last one then, literally it's saying any valid answer, but it has to be valid, I suppose. What has it said here? The difference, no new substances formed in a physical change. I don't actually really like that answer because that only talks about physical change. If you're writing as a sentence, then you should be saying no new substance formed for physical change, and you should be finishing off, there is a new substance formed in a chemical change. So I actually don't like that marking scheme there. I would only give half the marks for that, to be honest. It is worth 6 marks. I think we have done it better here. Okay, so we've made it very clear the difference between them by using the table. Physical changes don't make new substances. Chemical changes do make new substances. So that's a 6 marks, 15 out of 15. Again, hopefully you can see that that was a pretty straightforward, nice, easy question. All right, so we'll see you in the next one.